Hi guys, these are the worked solutions for paper 2 of your midterm. Just like with paper 1, watch through the questions that you need some extra help with, but don't feel the need to watch every single question the entire way through. So we start off with question 1, which is a bivariate data question. And the first thing it asks us to do is to find Pearson's product moment correlation coefficient, which is R. So to be able to do that, we need to go to the spreadsheet part of the calculator. And don't forget to label your X and Y there. So we'll call this column X and this column Y. And then I'm just going to type in all of those scores. Bear with me, or feel free to fast forward. 3, 4.3, 6, 7.1, 6, 7.5, and 6 again. I'm just going to check that those are right, because otherwise I will not end up with the right R value. So 4.1, 3, 4.3, 6, 7.1, 6, 7.5, and 6. Perfect. And then for the next column, 4.7, 4.6, 4.8, 7.2, 7.8, 9, 9.5, and 7.2. There we go. So I've got my data in there, and now to find my R value, I can go to Menu, Statistics, Stat Calculations, and then I've got two different options here, but I think actually if I look ahead, I can see that it then asks me for the regression equation. So rather than going into two variable statistics, which gives me R, I might as well go into linear regression, because that also gives me R, and then I can use it later for one part C. So let's head into there, and then my X list is X. My Y list is Y. All of the rest of it I can leave and just hit OK. There we go. So as you can see there, we've got the R value here, so that's 0.909. And then it asks us to interpret the relationship between Stan's score and Minson's score. Well, we can see that that correlation coefficient is both positive and strong as well. So those are the two words. If you've ever got 2 marks, you need to be commenting on the strength of the relationship and also the direction of the relationship, so if it's positive or negative. So I'll just put the relationship is positive and strong. And then it asks me to write down the regression equation, and now we're already ready for it. I just need to scroll up. So my regression equation is in the form y equals mx plus b. Don't forget that y equals part. Without the y equals, it's actually not an equation at all, and you've not included the variable y if you've missed that off either. And then what I can see is that my m is equal to 1.14. My B is equal to 0.578, and so I can substitute those into this equation. So my regression equation is y equals 1.14 x plus 0.578. Perfect. So then on to the next question, which says, use your regression equation from part C to estimate Minson's score when Stan is awarded a perfect 10. So if I take a look back, what we can see is that Stan's score is our X variable and Minson's score is our Y variable. So when we have Stan's score as a perfect 10, that means our X is equal to 10. And then we're trying to find out Y. So I'm just going to rewrite back out that regression equation, but I'm going to replace the X with a 10. So y equals 1.14 times 10 plus 0.5. Sorry, I've forgotten what it was. 578. And then I can just type that into my calculator to find out what y is equal to. 1.14 times 10 plus 0.578. So that's 11.978. And if I want to round that to three significant figures, that is, it's not 11, it's 12.0. So I've got their Minson's score when Stan is awarded a perfect 10. But then it says to state whether I think this estimate is reliable. Now remember, there's a few different things we need to consider. First of all, we can think about the correlation coefficient. Now that was a strong correlation coefficient, which might make us think it's reliable. The other thing we want to think about is, are we using X to predict Y? Yes, we are, so that would make us think it might be reliable. But then the other thing we want to think about is both, is it interpolation or extrapolation, and what about the context of our answer? So if Stan has a perfect 10, if I check Stan's scores, none of his scores are anywhere near a perfect 10, so we're definitely extrapolating. And the other thing to consider is that this is a competition with scores out of 10. So it's actually just impossible to score a score of 12 out of 10. And so I would say no, it is not reliable. And the reason why is because we are extrapolating. And it's impossible to score 12 out of 10. Right. The next question then moves us on to finding the ranks for each of their scores instead. I now appreciate that this was incredibly annoying to do with two separate pages. Sorry about that, guys. So I think what I'll do is I'll actually do the ranks over on the other page and then copy them across. The one thing that you will notice is they have already started to rank this data, and they've done that deliberately because they're showing us that they're ranking whatever B is as the 8th rank, so the lowest rank, and whatever G is as rank 1, the highest rank. So I'm just going to copy these ranks across and then finish off the ranking. So we have a rank of 8 and 8, 1 and 1, and I think that was, 4 and 4.5. So if I carry on ranking these, I can see that I'm ranking the highest score as 1, the lowest score is 3, so now I just need to carry on. So this was my highest score. The next highest score is 7.1, so that has a rank of 2. The next highest score is 6, but you'll notice we have 3 lots of 6. Now, all 3 of those lots of 6 should all have the same rank, right, because they're the same score. And we'll notice one of them already has a rank of 4. So we do know that it should have a rank of 4 just because it's already been ranked as 4. But the other thing to consider is I've ranked place 1 and place 2, which means my next 3 scores should take places 3, 4, and 5. And so because they're all the same, we give them the average of those 3 ranks, which is 4. So it makes sense that we're giving all these 6s rank 4. Now, as I carry on ranking, I want to make sure that I carry on after 5. So my next one should have a rank of 6, and that is the 4.3. And then 4.1 gets a rank of 7, and that 3 has a rank of 8. Now we're going to do the same thing for Minson's scores. So 9.5 is our rank of 1. 9 gets a rank of 2 because it's the next biggest. A rank of 3. And then we have 7.2 twice, so that should take up the spaces 4 and 5. So we go for halfway between those two, which is 4.5. And I know I'm right with that because 7.2 has already been given a rank of 4.5. And if they both have the same score, they should both have the same rank. So I've used up spaces 4 and 5. Now I need to give a rank 6 to 4.8 and a rank 7 to 4.7. So I've got all of my ranks there, and then I just need to copy those across into the actual correct part of the the answer booklet. So 7, 8, 6, 4, 7, 8, 6, 4, and then 2, 4, and the other one is 7, 8, 6, 4.5, 7, 8, 6, 4.5, and then I think that was a 2 there. Yeah, perfect. So I've got all of my ranks put into that table. Then the next question asks us to find Spearman's rank correlation coefficient, and the way we do that is almost exactly the same as what we already did, but we now put in these ranks as our lists instead of the actual scores. So I'm going to head back to the spreadsheet part of the calculator, and I need to be careful here because it'd be very easy to call this X and Y again, but I've already called something X and Y in my calculator today, so I don't want to do the same thing over again because it's going to end up causing confusion. So I'm going to call this SR for Stan's rank and MR for Minson's rank. And then I can just put those in. So 7, 8, 6, 4, 2, 4, 1, 4. And the same again, so 7, 8. Oh, sorry, I think I've made a mistake there, which I'm sure you've already noticed, because I've got 8 twice. That should have been, I totally messed that up. Be careful as you copy it across. Let me try that again. So it was 8, 6, 4.5, 6, 4.5, 3, 2. There we go. Now I've got the correct ranks to type in. 8, 6, 4.5, 3, 2, 1, and 4.5. There we go. So now I can go to menu, statistics, stat calculations, and I want to find my R value of this. It's not going on to ask me for another line of best fit because that wouldn't make any sense with the ranks anyway. And so I can just do 2 variable statistics. And then I just need to make sure I select the right one for each. So my X list was Stan's rank, so SR. And my Y list was Minson's rank. Oops, sorry guys. And then I can just hit OK. And as I scroll through and take a look, somewhere here, yeah, there is my R value. So if I copy that across, it is 0.933. Perfect. And then it asks us to comment on this as well. Again, we need to talk about the strength and the direction. So it is strong and it is positive again. So I can just put strong and positive. And then the final part of question 1 says, the commissioner believes Minson's score for competitor G is too high and so decreases the score from 9.5 to 9.1. And it then asks you to explain why the value for Spearman's rank correlation coefficient does not change. And if we take a look for competitor G with Minson's score, here it is. So he's saying to reduce that to 9.1, but our next highest score is 9, which means that it would still have a rank of 1, even if we reduced it. So that is what I will write here. It would still have a rank of 1. Right, let's move on to the next question, which is a question about a cumulative frequency graph. The first thing it asks us to do is to find the median using this cumulative frequency graph. And of course, our median is the one that is halfway through our data. Now, I definitely do not just want to take halfway through all of the distances. I need to use this cumulative frequency axes. So in total, my total cumulative frequency is 30, which means my median rests halfway through that total group of 30, which means it is at 15. And so now I just need to come along from 15 to the graph and then carefully drop down. And I want to read off this value here as my median score. Now, one thing to be careful of here is this is a fairly, well, I don't want to say it's a really hard axis to read off, but it's not completely simple. So I just need to be careful because here is 10,000, here is 15,000. So there are 10 little boxes there, but it's covering 5,000 with those 10 little boxes, which means each little box is going to be worth 500. So if I count it up, I've got 10,000. This is going to be 12,500. And then by the time I'm 2 more boxes on, that is 13,500. It then asks me to find the lower quartile. So the lower quartile is 1/4 of the way through the data. So kind of halfway up to 15, which will be at 7.5. And again, I'm going to do the same thing. I come along, I drop down. That one's way easier to read off. It's 10,000. And the upper quartile is up here, so at 22.5. But even if you're not sure if it's 22.5, it's obviously, with all these little boxes here, this is 3/4 of the way through the data. So I'm just going to drop down. And this is 2 little boxes after 15,000, which makes it 16,000. And then after that, it asks us to write down the interquartile range. And the interquartile range is my upper quartile minus my lower quartile. So that's going to be 16,000 minus 10,000, which is equal to 6,000. There we go, some nice easy marks, I think. Then after that, it comes to, if I'm honest, more of a kind of conceptual question, I suppose, because it says, write down the percentage of buses that travelled a distance greater than the upper quartile. So here is our upper quartile, and we want to know what percentage travelled a distance of more than the upper quartile. Well, actually, the clue is in the name of the upper quartile, because the upper quartile is 3/4 of the way through our data, which means 1/4 of the data is above our upper quartile. And so that means 25% of the data is above our upper quartile. It then says, it is known that 8 buses travelled more than m kilometres. Find the value of m. So this is a tricky one. I think most people for this question actually looked at 8 here, came along and dropped down. But that would be answering the question, 8 buses travelled less than m kilometres. We're interested instead in, I suppose, the 8 buses that travelled the furthest, so the top 8 buses that have travelled the most kilometres. And so if there are 30 buses in total, then our top 8 would be here at 22. So then I'm just going to come along from 22, drop down, and it's a tricky one to read off, but it's just under 16,000. Each of those little boxes is 500, and it's half a little box, so it's 250 less than 16,000. So let's say that is 15,750. And then the final question asks us to make a box and whisker plot for this data. And it also tells us the scale. It says for every 2 centimetres, that's going to be 5,000. Now, I'm just going to quickly check my lowest value and my highest value, because that will help me make my scale. So my lowest value is 0. My highest value is 25,000. And so if I start here at 0 and every single box is 5,000. So, sorry, every single big box is 5,000 because every 2 centimetres is 5,000. So 5,000, 10,000, 15,000. You really should have used a ruler, by the way. I just forgot to bring a ruler into this room with me, so I committed to doing it without it. But in an exam, you should definitely use a ruler. There we go. So we've got our scale down here, and it is important to also say, what is this scale about? So this scale is distance in kilometres. And now I can put in all of my values. So when I take a look at my cumulative frequency graph, as I said, my lowest value here is at 0. My highest value is at 25,000. So I'll do a line at 0, a line at 25,000. And then I just need to find my lower quartile, median, and upper quartile again. The lower quartile was 10,000. The upper quartile was 16,000, and the median was 13,500. And then I just need to join this up so it looks like a box and whisker plot. So it will look like this. There we go. If this is something you struggle to do, the one thing I would say is it's important to make your scale first and then draw your box and whisker plot above it. If you try drawing the box and whisker plot and then fitting a scale to it, it's just not going to work out. Right, the next question is actually the question I think was hardest on the paper, and if I'm honest, for next year, I think I will rearrange this and make this the question 4 and the other one the question 3. But here it was as question 3 in your paper. So as we look through, it says the living accommodation on a university campus is in the shape of a rectangle with sides of length 200 metres and 300 metres. And then they talk about these 3 offices for the management of the accommodation at A, B and C. And it tells us the coordinates of those slightly later on. And it says that each office is responsible for the students closest to it, which is why they've created this Voronoi diagram. So just to help me think, and to help you think as well, I'm just going to put in these coordinates on the diagram because I just think it will help me think. So this one is 100, 160, 140, and this one is 250, 100. There we go. And as I look through, it also tells me the equation of the perpendicular bisector of AC, so this perpendicular bisector here between A and C, is 5x minus 2y equals 615. And then it says the manager of Office C believes that he has more than 1/3 of the area of the campus to manage, and it wants us to find the area here. Now, the one thing I would say is, before we can do the rest of this, we have to notice that this rectangle has been split kind of symmetrically along here. And the reason I know that is because A and B are directly above each other. I can see they both have an x coordinate of 100. And that means that this is a horizontal line coming along here. And also this point here, again, is exactly kind of on that horizontal line. So this line and this line are symmetrical. And so when I'm trying to work out the area of this, what I think would probably be the best thing to do is to split it into a rectangle and a triangle and work out the area of this rectangle and the area of this triangle. Now, for the height of this rectangle, that one is nice and easy because we know it has a height of 200 meters because it says here that the rectangle has sides of length 200 meters and 300 meters. But the part that some people made a mistake on here was thinking that this distance here was 100 meters just because it looks like this line is coming down to meet this axis at 200, but actually we don't know that, and it isn't exactly on 200. So what can we do about that? Well, the good news is we know the equation of this line. So we can type the equation of this line into our calculator, and we could either graph it, or to be honest with you, if I think this through, I am interested in this point here on the line. And that point there, I know, has a y coordinate of 200. And so I can take this equation, 5x, was that a minus 2y? Yeah, minus 2y equals 615. And I can substitute in y is equal to 200 and use that to work out the x coordinate. So 5x minus 2 times 200 equals 615. And then we can either solve this using nsolve or using algebra. It shouldn't matter which. If I use algebra, I'll get that 5x is equal to 1015. And then I'm just going to divide that on the calculator rather than trying to do it in my head. I've got 1015 divided by 5. So 203 as my x value. But remember, all the way back up here, once you've substituted in that y value, you could definitely find that value of x. So I now know that this x value here, where this rectangle comes down, is not at 200, but at 203 instead, which means that the width of this rectangle is going to be 97 because it goes up to 300. And so the area of the rectangle is 200 multiplied by 97, which is 19,400. So we've got the area of this rectangle. Now we just need to find the area of this triangle as well. Again, with the area of this triangle, I know that this base here is 200, but I need to work out what this perpendicular height here is of my triangle as well. Now I know that it starts here at 203, but I don't know this value here. It looks like it might be 160, maybe, but I don't know, so I should check. And the way I can check is, again, I know the equation of this line. I do know that this line has a y coordinate here of 100, and so I can solve this to find my x coordinate. So I'm going to do exactly the same thing, but I'm going to substitute in 100 here instead. So 5x minus 2 times 100 is equal to 615. And then I've got 5x is equal to 815, and I'm just going to divide that. So 815 divided by 5 is 163. But again, you could just type this line here into nsolve as well. So to work out the area of my triangle, I'm going to do a half times the base times the height. The base, as we already said, is this distance here, so it's 200. And the height is the distance from 163 here to 203 here. So it has a height of 40. And then I can just type that into my calculator. So 0.5 times 200 times 40 is equal to 4,000. And so that total area is the 19,400 plus the 4,000, which is 23,400. I appreciate that was a bit of a beast of a question, but do note that if you had just assumed this was 200 and 160, you could still have worked this out. You'd have probably got 2 out of 4 marks here for that because you hadn't found these 2 coordinates, but that's okay. And then after that, all the other questions you would just get follow-through marks anyway. So it's worth kind of persevering, particularly with one of these long answer questions like this. Right. The next question then says, okay, now can you work out the areas of the offices managed by A, the areas, let me try that again. Find the areas managed by offices A and B. So as we said, this is symmetrical, we can see that, and so we know these both have the same size, and we can work out the total area, right? Because we know it's 200 by 300. So my plan is this: I'm going to work out the total area of this rectangle, I'm going to subtract off this area here, and then I'm going to divide it by 2 to split the area equally between A and B. So let's do that now. So 200 times 300 is equal to 60,000. Then I'm going to do 60,000 minus my total area that I had before, which was 23,400. I'm going to do that on my calculator. Actually, do I need to? Let's be sure I don't want to make a mistake for you guys. So 60,000 minus 23,400 is 36,600. And then that is for both offices A and B. And I'm going to divide that by 2. So that is 18,300. But remember, if you'd have subtracted off whatever area you'd worked out for office C and followed through with this, you would have got all 3 of those marks. Right. Then it says, state a further assumption that must be made in order to use area covered as a measure of whether or not the manager of office C is responsible for more students than the managers of offices A and B. Now, if we think this through, just because manager C does have more area, it doesn't necessarily mean there are more students living in that area. The only way that would be true is if the students are kind of evenly distributed across all of the areas. And so that's what it means when it says state a further assumption. So our assumption is that the students are evenly distributed across all areas. Nice. And then it says a new office is to be built within the triangle formed by A, B, and C at a point as far as possible from the other 3 offices. Find the distance of this office from each of the other offices. Now, we know this is going to be kind of like a toxic waste dump problem because it's saying we want to build a new office as far as possible, which means that new office is absolutely going to be on this vertex here between all of the offices. So the first thing I need to do is I need to know the coordinate here. Now, we've already actually worked that out because we said that we knew this point had a y coordinate of 100, and we worked out the x coordinate as 163 down here. And so that's the coordinate of this office, and that office would be an equal distance from all of these. So if I'm honest, I could use the distance formula for this, but actually it's on a horizontal line from this office. So if I just look at this, it's going at 163, and then this office is at 250. So if I do 250 minus 163, I get that distance is 87 between those. I could have also used the distance formula, but it just seemed like overkill in this situation. So I'll just write down 250 minus 163 is 87. There we go. Right, that's the end of question 3, which was definitely the hardest question on this paper. I'm sorry that that wasn't your final question. Sometimes it's hard to know until people have done it. But what that means is now we're finishing off with question 4, which isn't too bad. So here it tells us about a survey that was conducted on a group of people. And the first question asked how many pets they each own, and the result is summarised in the table below. So there were 20 people who owned 0 pets, 45 people who owned 1 pet, and so on and so forth. And then it says, write down the total number of people from this group who are pet owners. So we've got to be careful here because we're actually not looking for the total frequency because these people who own 0 pets are not pet owners. And so I'm just going to add up these values here. Sorry, actually, I know the answer because I've marked so many papers on it. If I add up these, it's going to be 140. If you had an answer of 160, unfortunately, that was wrong. And the reason why it's wrong is because if you own 0 pets, you are not a pet owner. Right, the next one said, write down the modal number of pets. So that was the most common number of pets. And that would be the number of pets with the highest frequency, which is this one here. So here we've got the highest frequency, which means 1 is our modal number of pets. And then finally it says, write down the upper quartile for this data. Now, one of my options would be to work out my total frequency, work out where 3/4 of the way through my total frequency is, and then that would tell me my upper quartile for my number of pets. We could do that. But I also just wanted to remind you that we can do this on the calculator as well. So I can call this pets as my column 1. And maybe people as my column 2. And then I'm just going to quickly put in this data. So 0, 1, 2, 3, 4, and 5. And my frequencies there. So 20, 45, 40, 30, 20, and that has not gone in, and 5. And then I can go into menu, statistics, stat calculations, and be careful here. This is 1 variable statistics, not 2 variable statistics, because the number of pets owned is the variable, and this is just a count. This is just how many people. So it's a frequency instead. So 1 variable statistics. We only have 1 list of actual variable data. So I'm going to put that in as a 1 and press OK. And then my X list should be pets. My frequency list then is my people list. And then I can just hit OK. And as I scroll down, if I look through, there it tells me my Q3 is equal to 3. There we go. Right. Now it kind of moves on to a hypothesis testing question. So it says the second question asked each member of the group to state their age and their preferred pet, and the data obtained is organised in the following table. And the first thing it asks us to do is just to write down the ratio of teenagers to non-teenagers in its simplest form. So first of all, I'm just going to write down the ratio of teenagers to non-teenagers, which is, would just add this up and it gives you 85. I know that because I've marked lots of these assessments. And if you add this column up, it's 75. So that's our ratio of teenagers to non-teenagers. And then to put it into its simplest form, we need to divide it through by any common factors. So I think it's pretty clear we've got 5 as a common factor. So if I do 85 divided by 5, I get 17. And if I do 75 divided by 5, I get 15. Right, a slight change of location for the final part of the final question because I forgot to check the timetable and somebody was coming into the classroom, but that is okay. We are in a new place, but carrying on with the same question. And to you, it looks like nothing happened, I suppose. Right, so we finished off part 4D, and now looking at 4E, it says a chi-square test is carried out at the 10% significance level, And for the next two questions, it asks us to state the null hypothesis and the alternative hypothesis. Now, the challenge here is that there are, of course, two different types of chi-squared hypothesis test. And so we need to be clear on which type of chi-squared hypothesis test it is before we can write down the null hypothesis and the alternative hypothesis. Now, our two options are it's either a test for independence, also known as a two-way test, or it's a goodness of fit test. Now, if it was a goodness of fit test, we would be talking about an expected distribution and seeing whether some observed values met our expected distribution. And that is definitely not what's going on in this question. Instead, we have two different variables and we want to know if they're independent or dependent on each other. So we've got age and preferred pet, and we want to know if they're independent or not. And so that means this is a chi-squared test for independence, and so I need to make sure that my null and alternative hypothesis reflect that. So as we know, the null hypothesis for this type of test is that our two variables are independent of each other, and our two variables are age and preferred pet. So I'm just going to write that down. Age and preferred pet, are independent. And then our alternative hypothesis is that they are not independent. Right. It then asks us to work out the number of degrees of freedom for this test. And for this type of test, our degrees of freedom is rows minus 1 multiplied by columns minus 1. And so my number of rows is 1, 2, 3, 4. And my number of columns is 2. So 4 minus 1 multiplied by 2 minus 1, which is equal to 3. And then this is an interesting one. It asks us to work out the expected number of teenagers that prefer cats. Now, there is a way to do this kind of by hand, I suppose, but I just wanted to remind you that your calculator actually can come up with a matrix of expected values as well. And so I just want to show you how to do that. So if we go back to our data, and here's the thing, is it's going to take us a little while. We need to store it as a matrix and then do some calculator stuff with it. But the next question is actually asking us to do a chi-squared hypothesis test. And so why not just kind of do this anyway, because we're going to need to do it for this second part as well. So I head into the calculator part of my calculator to make this matrix. I go to menu, matrix, create matrix, and my number of rows is 4. My number of, that was me. My number of rows is 4. I can tab through actually and then get to OK. And I've got my matrix and I'm just going to write everything in. So 23, 32, 35, 23, 16, 13, 11, and 7. Actually, sorry, I don't know why I press enter. It doesn't really matter. I just need to bring that answer through. And then actually what I want to do is store it as a letter. So I'm going to store it as the letter A. There we go. And now I've stored that matrix. Now I'm able to do my goodness of, sorry, not my goodness of fit test. I apologize. My test for independence or my two-way test. So I'm going to head into menu, statistics, stats tests, and I look for that two-way test, and it says what's the observed matrix, and it is A. So I can press OK on that. And now we've got all our p-value and stuff that we'll use later, but remember, it says this expected matrix and the ... But once I've got this all set up, I can hit var, which is variable, and then I just scroll through and, I missed it, sorry, where it says stat exp matrix, That's the expected matrix for our test. And so if I press enter on that and enter again, here we go. This is my table of expected values. So I just need to double check again what it was actually asking us for. It was asking us for the expected number of teenagers that prefer cats. So if I look at the position of that, this top box here is my teenagers who prefer cats. So if I check on my expected matrix, that's 29.2 as my expected value. Perfect. And then it asks us to state the conclusion for this test. Well, whenever we're doing a hypothesis test, we need to compare the p-value with the significance level, and then that will help us reach our conclusion. Now, if I look back up, my p-value is 0.208, and our significance level was 10%. So that means 0.208 is bigger than 0.1. So my p-value, what am I doing? My p-value is bigger than my significance level. And because of that, that means that I accept my null hypothesis. And that is it. So this is me stating my conclusion for the test. Right, that is it. The entire paper completed. Let me know if you do have any questions about it.